Welcome to week 6 of Basic Soil Science. Week 6 is about rocks. Rocks are the source of soil. It has a reading assignment in it. And it's taken from your textbook. I believe the textbook is Soils and Foundations, and it's chapter 1. It's not an exciting read, but it's essential that we understand. I said essential, I'm not so sure about that. But it's good to know where soil comes from. We're going to talk a lot about that, or the book is. And we'll probably have an essay test over that. Week 6 also begins the preparation for actually classifying soil using the AASHTO and or the Unified Soil Classification System. AASHTO, in addition to classifying soils into particle sizes and things and other parameters or engineering properties, plastic, we have liquid limit, such as that. But for the soil classifications, there's like, 7 in AASHTO. Let's see. We have all my papers out here in front of me. But it goes from, like soils from A1 all the way through A8, and then stuff in between, like A26, A17, and all of those different subcategories. But it has general classification, that's sands and gravels, coarse and fine, and it has other things like sand, fine sand, and those kinds of things. But this video is going to focus on how to calculate the group index. And as you get looking up here, you can see I have a little bit to talk about. Many of you probably are familiar with PEMDAS, which is an acronym for the order of operations when you're solving complex mathematical problems. That includes brackets and parentheses and some exponents, and things like that. PEMDAS tells us what to eliminate first. So that's what I've got written down here. I have the actual acronym here, and then what the P stands for. The first thing that we eliminate is parentheses, anything that has parentheses in it. And look here, we've got parentheses out the wazoo in this, which is a simple problem once I get to that. Then we look for exponents. There's no exponents. Exponents is like something squared or something to the third power, but we don't have any. And then the next thing we look for is addition, and now we do have that. And we want to be extremely cautious about addition, even though it's not very fancy, and it's so important when to add, when not to add. This is the problem. Group index equals this plus this. Now, to get down to this plus this, we've got to simplify all this stuff. And here we have some variable. Well, let's call it a variable. For instance, here we need to substitute values for variables. In other words, this F right here stands for the percent of fines passing the number 200 sieve, and that's going to vary. In our particular case, it's given under our givens. 33% passes the number 200 sieve. So 33 would go right there where that F is. And look, I've already done that because I didn't want to spend a lot of time erasing in this. I went ahead and did that. I got this. As I said, this is the problem. This plus this. That's it. But we got to simplify it before we can add or subtract, or add in this case, to its lowest, simplest form. Let's call it that. You know, you can go back lowest common denominator when you're working with fractions. The theory is a little bit the same. The process is different. Let's just look at it that way. So we're going to look for parentheses first. Here's the problem. This plus this. Nothing more, nothing less. Now, and you can see it continues on both sides. It's getting simpler and simpler. I don't know if that's a word, but it is. So we have to maintain the functions, the adding, the parentheses usually indicates a multiplication. Let's go through this one right quick. And we would put 200 here. And that's a minus sign. You may have trouble determining that, but I'll take you through it. Minus 35. Now, in the past I've said 35 is a constant. Well, it is. But what is that? It's significant, isn't it? Because 35 is the breaking point between coarse grain and fine grain. So it's there for a reason. It's supposed to let you know the percent of gravel or coarse grain. And it does that by taking the percent passing the number 200 sieve, which is the fine grain. Where is that? There it is, 33%. And it subtracts that breaking point between fine and coarse, 35. So things that are over 35% passing are coarse grains, bigger. Things that are under 35 are fine grains, smaller. So let's continue on. Let's go down here where I've got 33 minus 35. But we'll stay up here in this shaded stuff. The next step is to be careful. We can't, the mistake I made when I first started teaching this was I added this to this and I multiplied it times that. That was a big mistake. I like to never figure that out. So what we got to do is follow that PEMDAS. The first thing we look for is parentheses. Well, let's just do it right here. I don't think it matters when, but as long as we don't do this before we do parentheses. PEMDAS says do parentheses. So let's do that right here. So the liquid limit in our case is 46. So 46 goes right here, as I think I have already done, maybe. Well, I hadn't, I will do it. We can do that in our head. So 46, if I put 46 right here for the liquid limit, and that's given right here, minus 40 is 6. And now you go down here past all of these engineering properties to back to our problem that has values. So 6 would go right here because I got rid of the parentheses, right? I took 46 minus 40 and that gives me 6. Right? Yeah, right. Okay. So now we got a value here. Let's see what's going on over here. This is 100, 0 0.100. And it's multiplied times 33 right here, which is the percent passing the number 200 sieve, and that is minus 15. So 33 minus 15 is 18. You see that? I put it right here, and that's where that's fine. That's where it can go right there, because it's right here before this one. This is plasticity index, and that's 17 minus 10, which is 7. Right there it is. So we'll get to him in a minute, but we're done with this up here. We're not done with this guy yet, though, because we have this addition in here that can really throw us off. If I add this to this, I'm going to get, what am I going to get? 0.2 plus 0.005 is where'd it go? Let me find it again. Here it is again in the number area. So I don't want to add it. If I added it, I would get it would mess things up. What it's telling me to do first is to multiply right here. This parentheses and this parentheses is telling me to multiply this, not this, but this. Not to add yet. I can't add these. I multiply this times liquid limit minus 40. And again, what did that give me? It gave me 6. So that puts us down here. Still, we have to deal with this, but now we've got rid of these parentheses, so we're at 6 right here. Now, still got to deal with the addition sign, but we had to get rid of the parentheses first, right? Notice this character lurking right out here. He's a minus. You know where he came from? He came from right here, because this was 33 and that is 35, that constant I told you about. And when you take 33 minus 35, you're going to get minus 2. And look and see that this is where the minus 2 comes from right here. So we drop down, we have the minus 2 is going to stay with us a while. But let's go deal with this since we have the 6. Now, what is 0.005 times 6? Is that, I got down here that it's 0.03. And if you take your calculator, and just to be sure, I'll do that, but I won't do it on everything. But I want to do it right now because I have said that's 0.03, but 0.005, 0.005 times 6 equals 0.03. So we're good right here. Now, you notice I'm not messing with this yet. I'm staying over here to the left of the plus sign. So we're good down to here, but we have gotten rid of parentheses here, and we have a number here of 0.03. Now we can add. So we take the 2 and bring your minus 2 down. It's a multiplier. We take the 0.2 plus 0.03, and that will give us 0.23. We still have these guys to deal with, and we'll get to that. So we have a multiplication issue here still. We've got brackets which work the same as parentheses, so we got to get rid of them. And it's minus 2 times 0.23, which is going to give us a minus 0.46. Now, let's see if we can get on down with this. Look at this stuff. I'm way back up here. So what is 17 minus 10? That's 7, right? And what did I say? The plasticity index minus 10 was 6. We did that. Where did the 18 come from? Oh, the 33 minus 15. The 18 is here. So, and we have this to deal with. We can deal with this stuff here. We're not going to add this stuff, anything here yet. We got to simplify. We got to catch up. See, we're already down just as one value here. So let's catch these guys up. What's 33 minus 15? That's 18. Right there it is. What is 17 minus 10? That's 7 right there. So what is 18? What is 0.01? See, that's a PEMDAS. We're back to the parentheses. What is PEMDAS? I'm sorry. What is 0.01 times 18 times 7? Well, that's multiplying right there. We got to get rid of those. 18 times 7 is 126. And if you multiply that by 100, you're going to get 1.26. So we're just dang near done now, because we've kind of stayed up with it. You can work this whole side first, and then work this whole side, and that's a good idea. But just remember what side of the plus sign you're on. See, we stayed on the left-hand side all the way here, and we stayed on the right hand. So now we're down to real simple stuff here. We have a minus 0.46 plus 1.26. So what is 1.26 plus a minus 0.46? Well, it's 8/10. 8/10 in group indexes, when you get a fraction or decimal in this, you round it up next to the next whole number, which is a group index of 1. Now, this will be on video. Go back and look at it. Write it out yourself. If you recall, all we did was do the functions inside the parentheses, and that gets rid of the parentheses. The real cautionary part is this guy right here. We cannot add this and then multiply it times this 6 that came from liquid limit minus 4. We cannot add it first and then multiply. We have to multiply this 5 thousandths. That's really the percent sand, I think. So we got to multiply that times this 6. That's a result of this function, and that brings us on down to a single number. But yet, it's still got to be multiplied. So 5 thousandths, let's 0.005 times 6 is 300ths. And here's our minus 2 that's followed us all the way. Multiply that minus 2 times 0.23, which is the result of, now we added 2 plus 0.03, that's 0.23. So minus 2 times that gives us minus 0.46, and 1.26 minus plus a minus 0.46 gives us 8/10, which rounds off to 1. So there you have it. That's how to calculate a group index using PEMDAS, and I wouldn't know how you would do it without using PEMDAS. And there may be some of you out there that are, a little sharper at math than I, and you may see better ways to do it. But whatever way you do it, you need to come out with this one if you're using the variables or the properties these properties are tests, right? Liquid limit came from the lab, excuse me, it's a liquid limit of 46, which is, liquid limit is part of the Atterberg limits. So the plasticity index comes from, I think it's the liquid limit minus the plastic limit. And we didn't have to do that. They did it for us here. So there. And here's the problem right here. This is the simple problem. Same as this, except this has most of the calculations done, especially when you get down to this next step. These are steps I took. I didn't go all the way across. I didn't do this and then this. I went down. And it doesn't matter as long as you follow the rules of PEMDAS. So, you're not going to be even allowed to say, when you get on the job site, this is a job for an engineer to say, okay, I agree with these calculations. This is AASHTO. This is like, 95% compaction stuff. This is highways and air and runways, airports. This is gotta be this of all, gotta be this. Now, unified soil, and we'll go through that, but I wanted you to go through this AASHTO just to see the calculations, just to know what's going on out there if you get in, when, not if, when you get in a management position. When you know that your compaction is this is where it's all gonna come from, right here, to get the group. Group 1 is the group has an inverse correlation. In other words, the lower the group number, the better the soil. Soil over 10, 15 with group index, not group number, group index of 15 and above is poor. Not usable for anything really. But when it's 1, it's exactly what you want. Okay, so you may have questions, and you will have a tailgate coming up in this week that you're going to get to do this again, and it'll be graded. So just take your time and follow PEMDAS, and the instructions, I feel, are clear. There's a video prior to the actual problem, so you'll get a refresher on this. It'll probably have different values that this guy goes over, but it's an easy to understand video. Now, I don't think I want to talk about anything else from let me look at week 6. There is that must watch that's in the overview, and then there's that chapter 1. I'm not sure what I put. There's a video for the overview, and I'm not real sure what's in there. I think I can look right quick. Oh my goodness, it's me going over this chapter 1 and the rocks, and rocks are boring enough without me in it, but I do have some things I want you that will refresh your memory on some things that I really want you to focus on, because the essay test is I don't care if you use your book on this week 6 preview, I think it's called. Okay, back to work, and thanks for joining me. And if you have questions, 405-684-6828, give me a call. And that's all.